And here's our video notes for Lesson 2, Unit 9, the key features of parabolas. So here's all our learning targets. We're going to be able to graph a quadratic function using a table. We're going to be able to use the key functions, features of a function. We're going to identify the key features of a quadratic function from a graph, and identify the key features of a quadratic function from an equation. So let's get some definitions out of the way. Highest or lowest point on a graph of a quadratic function. Quadratic function, remember we're talking about x squared functions. They look like parabolas. Use. The highest or lowest point is called the vertex. Okay? A line that passes through the vertex of a parabola and divides the parabola into two symmetric parts is called the axis of symmetry. Standard form for a quadratic function is, and we've done this before, so maybe you remember, this is going to be y equals a x squared plus bx plus c, where a, b, and c are the coefficients, the numbers. Vertex form for a quadratic function is y equals a times x minus h squared plus k. Okay, if a parabola opens upwards, the vertex is a minimum, and the y-coordinate of the vertex is the minimum value. If the parabola opens downwards, the vertex is a maximum, and the y-coordinate of the vertex is a maximum value. Okay, so that's a lot of definitions with this picture right here. Here's a parabola, this U shape, this dotted line right here that goes right through the vertex, goes through the x value of the vertex, is the axis of symmetry. And this is called the vertex right here. This point right here is the vertex. It's an XY pair, ordered pair. Okay? So those are definitions. So let's go on to example 1. Identify the vertex axis of symmetry maximum or minimum value for each graph. So we're going to look at this picture. Where's the vertex? Well, the vertex is this point right here, which is what? It's 1, negative 4, that ordered pair. Axis of symmetry is the line, and I'm just going to draw a dotted line right here. It's a line that goes through the x-coordinate. It splits it in half. So the axis of symmetry, it's a vertical line. We know vertical lines start with x equals, and it's going to be x equals 1. That's the equation of the axis of symmetry. It has to be x equals 1. Can't just be 1. It has to be x equals. Is the vertex a minimum or maximum? So is this the highest or lowest point? This vertex is a minimum. So min. And what is the minimum or maximum value? So they're looking for the minimum or maximum. When they're looking for min or max, we're looking for the y value. So the y value is what? Negative 4. It's minimum. Doesn't go any lower than negative 4, but it goes higher. Alright. That's it for example 1. We got to identify those key parts of that parabola. So another part is identify the key features of quadratic from an equation. So instead of a picture, we're going to look at it from an equation. So graph the following functions using the graphing calculator and complete the table below. So if we have our graphing calculator, we can turn it on and we can put in our y equals. We're going to clear it out. We want to turn off our plot. We don't need that from last unit. That can go off. And parentheses, x minus 3 close the parentheses, squared plus 5. And we're going to graph it. So I have to hit zoom 6 to get back to my standard window. And let's see, what is this? Vertex looks like it's 3. And up how many? 1, 2, 3, 4, 5. 3, 5. Let's just graph this other one before we answer the other question. So I'll go to y equals. I'm going to clear this out. I'm going to say -2 parentheses x plus 2 close the parentheses all squared minus 1. We're going to hit graph. And let's see, what is that? -1, 2, probably a -2, comma, -1. Okay, what do we notice about the vertex? 3, 5. What do I notice? Well, I have a 3 and a 5 in here. -2, -1. I got a 2 and a 1. So +2, -1. I got a -2, -1. Here I have a -3, +5, and I have a +3, +5. So this number on the outside looks like it stays the same. The number on the inside is opposite. So what do I notice? I notice opposite inside the parentheses. And same on the outside. Oops, the outside. So the y. And the x on the inside. So that x is the opposite on the parentheses, and the y is the same. That's what I noticed. Okay, and that's our trick. So we can identify the vertex, axis symmetry, maximum or minimum value for each quadratic function. So for number A, does this open up or down? Going back to that first lesson, this is positive, it's going to open up. Okay? If this number is positive, it opens up, that A value. There is no A value, but it's +1, so it opens up. Vertex. Well, going back up here, if I have it in this form, vertex form, okay, well, it's opposite on the inside, so -2, and the same on the outside, -4. Opposite inside the parentheses, same on the outside. And you remember vertex form was y equals a times x. If we put it in here, x minus h squared plus k. So that was vertex form. H and k are the vertex. Remember, h and k are the vertex. So the opposite on the inside of the parentheses, same on the outside. Axis symmetry. I know it's x equals, it's a line that goes through the x coordinate. X equals -2. Is this vertex a maximum or minimum? Well, this opens up. If it opens up, we draw a quick picture, it opens up like this, right? So that's going to be a minimum. And that minimum value is going to be the y value. So the minimum value is 4, -4. Okay? So if we look at example B, does it open up or down? Well, this -4 in the front is going to make it open down. Vertex is going to be inside the parentheses, is going to be opposite. So -3, it's going to be a +3 out here, and a +6. Same on the outside. My x and y. Axis of symmetry. Vertical line, I know it's x equals 3. Whatever goes through the x coordinate. Is the vertex a minimum or maximum? So if this opens down, quick picture, it'll open like this. So that would be a maximum. And the minimum or maximum value is the y value, and that's 6. So this was just showing us off our graph, but we don't even have to graph it. We know some certain features and key features here. So it opens the vertex x symmetry is it a minimum or max and the minimum or max value. Okay. Part 2, when the quadratic function is given in standard form, what is standard form? Y equals a x squared plus bx plus c. That's standard form. We have to find the vertex using a formula. This is going to be important. So to find the vertex when it's given in standard form, we identify a, b, and c from the equation. So I've figured out what those numbers, those coefficients are. The x-coordinate of the vertex is given by this formula, important formula, x equals negative b, or the opposite of b, over 2a. Negative b over 2a, that's what the x-coordinate is of the vertex. And then we're going to plug that value in from step 2, the x-coordinate, to get the y, to find the y value. Let's do an example and see how that works. So, find the vertex of the quadratic function by completing the table. This is in standard form, ax squared plus bx plus c. So what is a? A is going to be 1, b is going to be negative 4, c is going to be 5. So the x-coordinate, I know that my x-coordinate equals negative b over 2a. So x equals negative 4. So negative 4 over 2 times 1. Negative 4 turns into positive 4. 2 times 1 is 2. 4 over 2 is 2. So my x part is 2. How do I find this y part of the vertex? Well, I take this and I plug it into the original equation. So y equals, not x squared, but wherever I see an x, I'm going to put a 2. So 2 squared minus 4 times 2 plus 5. So 2 squared is 4. Negative 4 times 2 is a negative 8 plus 5. 4 minus 8 is going to give me negative 4. And negative 4 plus 5, I'm going to put it up here, and that's going to equal a positive 1. So my y-coordinate is 1. So we find the x-coordinate using negative b over 2a, or the opposite of b. The opposite of negative 4 is a positive 4. Over 2a, I get 2 for the x-coordinate. I take this x-coordinate, and I plug it back in to find the y. So when I plug it back in, I get 1 for the y. So my vertex is 2, 1. It's going to be important. We have to know this. Negative b over 2a. Alright, so example 4. Identify the vertex axis symmetry, maximum or minimum value for each quadratic function. So this is in standard form. Ax squared plus bx plus c. So does this open up or down? Well, that negative 2 is going to make it open down. Vertex. Since this is in standard form, what am I going to use to find the vertex? I'm going to use x equals the opposite of b, or negative b over 2a. So I'll list my a, my b, and my c. My a is negative 2, my b is negative 12, and my c is negative 19. So I'm going to plug it in up here. Opposite of b, so not negative 12, but it's going to be a positive 12 over 2 times negative 2. So 12 over negative 4, which is going to give me a negative 3. So this is my x value, negative 3. How do I find that y value? Well, I take this negative 3 and I plug it back into the formula. So y is going to equal negative 2x squared, but it's going to be negative 3 squared, minus 12x, but it's going to be 12 times negative 3, minus 19. So negative 3 squared is 9. 9 times a negative 2 is a negative 18. Negative 12 times a negative 3 is a positive 36. And minus 19, and we'll do it right here. What does that equal? Negative 18 plus 36 is a positive 18. positive 18 minus 19 equals a negative 1. So I found negative 3, negative 1 to be my vertex. The rest should be easy. Axis of symmetry is x equals whatever that x coordinate is. Negative 3. Line that goes through negative 3. That's the axis of symmetry. Is the vertex a minimum or maximum? Well, if this opens down, that vertex is a max. And I know that the minimum or maximum value is the y. So negative 1. Okay? So we have to use that negative b over 2a. It's in standard form to find the x coordinate. We take that x coordinate, plug it back in to get the y coordinate of the vertex. And then we're doing everything we did up top. Alright? Couple more. Example 5. In each of the following functions, determine if the vertex is a minimum or maximum or minimum and use a complete sentence to explain why. So, this sentence we're going to have to know word for word. So, is this a minimum or maximum for a vertex? Well, hopefully we can all know that it's a minimum because that 2 is positive. So, the vertex is a minimum because the a value, so this 2, the a value is 2, which is positive. There's my clock going off again, I know. So the parabola opens up, causing a minimum. Okay, we have to talk about that a value being positive, and if it's positive, it means the parabola opens up, which also means a minimum. So we need to know this stuff. Opens, it's positive, means it opens up, which causes a minimum. You have to have all three of those pieces in your sentence. 6 says write an equation in the form of ax squared plus c that satisfies the given condition. So we want to write it in this form. So a parabola that opens up. Well, I know y equals, how does it open up? This a value, I could say a positive 3. So y equals 3x squared plus 2. That opens up, it's in that form. And that's it. So what I want you to do on the front page of the notes, right by the learning targets, I want you to write a star to know that you watched this video. So put a star by the learning targets. And fill out, after watching this video, do the U-tries, example 7 and 8 we're going to do in class tomorrow. You guys have the U-tries for homework, and we'll see you tomorrow.